Today we'll be talking about multiplying and dividing rational expressions, and we'll talk about complex fractions a little bit. Okay, one important fact that you need to know the difference between the two is you do not need common denominators when you multiply or divide. Okay, it's just as simple as that. If you are trying to get common denominators, you're going to have to factor it out in the end, and you're just making your job a little bit harder. Okay, but please understand you do not need common denominators when you multiply or divide. You only need that when you're adding or subtracting. Okay, so straight up you could just multiply straight across and just work with it that way. So let me change that to an A. There we go. Just make this problem a little bit easier to work with. Okay, so multiplying straight across, we would actually get 40 on top, and then on the bottom we would have 3A to the 5th. Okay. Now, as you can see, normally I would try to go and say, oh, cross cancel and do something like that. But right here, I can actually, if I just go straight across right here, okay, and then try to simplify, that's another method as well. Now, 40 over 3 does not reduce any, and there's no A up here to really reduce. So this is actually your final answer. Okay, now on this one, you can try to factor out some stuff. So I would probably factor out a 5 out of this. So this become x plus 2, 5 times x plus 2. And then out of here, I would factor out a 30 and have this be x plus 2 as well. Okay, and then right here, you could also factor out a 2 as well. So 2 times x minus 1. Okay, now when you get done, what you're going to do is just multiply everything together. Now I would put this in parentheses, and I wouldn't do any distribution per se because you haven't canceled out everything yet. So we would get 30 times x plus 2 times 4x plus 1, okay, and that's all on top. And then on the bottom we would have 5 x plus 2, and then, well, we could actually move the 2 right here, so it would be 5 times 2, so that would be a 10. So that would be a 10. See, and when you rewrite it, you catch mistakes like what I just made right there, x minus 1. Okay, let's move this back a little bit. Okay, and then when I rewrite it, I'm going to be able to see some really clear stuff that I can have. Okay, now 30 and 10. 10 goes in each one, so it goes in here 3 times. So I just reduce it like a fraction in here once. Okay, and then up here I have the same set of parentheses, so these are going to simplify to 1 as well, because remember, dividing anything by itself and you get 1. Now you can feel free to go ahead and distribute if you want, if you're really needing to. Okay, and you could get 12x plus 3 on top, and then on the bottom you're just going to have x minus 1. Okay, now you do need to still state your extraneous solutions. Okay, notice how I didn't state any extraneous solutions because obviously a cannot be 0 over here. Okay, but right over here we already know x cannot be 1, but we also need to remember that x cannot be 2. Okay, not 2, but negative 2. Okay, so not only can x not be 1, but x cannot be negative 2 as well. Okay, now when you're dividing, what you can do is you can either factor and then multiply by the reciprocal, or you can just go ahead and multiply by the reciprocal and then factor. It's up to you how you want to do it. I like to get everything nice and arranged before I start cross or multiplying. So on this one I'm going to factor. Oh, and here's another hint: do not cross factor on this one or cross multiply because we do not have an equal sign in the middle. Okay, so first off, factor makes your job a whole lot easier. So what times what is 8 but adds up to 6? I believe that would be 4 and 2. Alright, now on this bottom, we're going to have what times what is negative 2 but adds up to 1, and that would be x plus 2 and x minus 1. Okay. On this one, this just has a greatest common factor, so this would be x plus 4 And this one would just be 2 parentheses x plus 2. Okay. Now, when I say multiply by the reciprocal, okay, that just means we are going to be flipping this one. Okay, because we're multiplying by the reciprocal. So in other words, it's going to look like this. Okay, now if you remember over here, I went ahead and multiplied everything and then simplified without cross-simplifying. Over here, you can actually cross-simplify. So before I multiply, I'm just going to go ahead and simplify. These two are going to be the same, so those two simplify to 1. Okay, and you could have done this one and this one, but you cannot do these two. Okay, this x plus 4 is the same as this x plus 4, so those simplify to 1. And if you notice, nothing else is going to simplify. Okay, so when I write my final answer, it should be, and you can distribute with your final answer, it's totally up to you, 2x plus 4 over x squared minus x on the bottom. Okay. All right, now when you rewrite it like that, you do need to state your extraneous solutions, your extra solutions, your excluded solutions, whatever you want to call it. Okay, so x, and so I'm going to include it from here. So x cannot be -2, x cannot be -4, and obviously we know x cannot be 0 here, okay, or +1, because that would be an issue as well, but we don't need to state them because it's already stated by the actual problem, okay? Now, if you'd like, you can actually state them and everything, and it's definitely not going to harm you, but just so you know, sometimes when they ask for extraneous solution, they're not going to ask you to actually put it out, okay? All right, let's take a look at complex fractions. Okay, so now on this one, I know I've talked about it before, try to factor it and everything. Okay, with complex fractions, simplify the top portion, then simplify the bottom, then multiply by the reciprocal. Okay, so the top portion, I can't simplify x plus 2 because that's been factored, or that's already at its lowest common factor. And same thing with 3x minus 1, so I'm going to work down here. So this I can factor out in x, so this becomes x plus 2. Okay, and on the bottom I'm going to factor out a 2, not a 3 like I originally typed, and I'm going to get x, or 3x plus 1. Okay. All right, now what I'm going to do is I'm actually going to multiply it by the reciprocal of the bottom portion. So on top I'm going to have, and a lot of you guys are probably going, oh man, too bad that wasn't a 3x minus 1. Yeah, because then we could cancel it out, or sorry, simplify to 1 and then work with it. Okay. All right. Now, when you do that, make sure you cover this up or you scribble it out, whatever you need to do, because you might get confused by looking back at here. So now that we're multiplying by the reciprocal, this is just a simple multiplication problem. These two are going to simplify to 1s. Okay, no matter how hard you want to try, do not simplify those two. Okay. And if you notice, nothing else is going to cancel out. So I'm going to be left with 6x plus 2 on top, and then on the bottom I'm going to have 3x squared minus x. Okay. All right, and state your extraneous solutions. So x cannot be -2. 0. Remember, when x is alone, it's considered, 0 is an exclusion. Remember, if you're, once again, if you're having a hard time seeing it, set up each one equal to 0, and that will tell you the extraneous solution. Okay, or the non-extraneous solution. Okay, because some of these weren't simplified to 1s. Okay, so x cannot be 0, so that's where that one comes from. We minus the 2, and x equals -2. That's where that one comes from. Now this one's a little bit trickier. You're going to add the 1, and so we get 3x equals 1, and then we divide by the 3, and we get x equals 1/3. And if you check that out, 3 times 1/3 is 1, and 1 minus 1 is 0, and that's an issue. Okay, so your other solution, your other Now, this is, remember, this is not called extraneous, but this is a restriction. X cannot be 1/3. Okay? It can be every other number but those three. All right? And that's what we're talking about when we're talking about this stuff. So complex fractions, not that hard if you just take it one step at a time. Okay? All right, that's it for multiplying and dividing rational expressions. I'll talk to you later. Bye.